Hello everyone, today in this video we learn how inverter works. First we understand what is inverter. Inverter is a device which converts DC supply to AC supply. Before we understanding the proper working of inverter, we have to understand what is DC and AC supply. First we go through DC supply. DC stands for direct current. DC current moves only in one direction. In DC, electrons move from negative terminal to positive, else current move positive terminal to negative. It do not change its value according to time. It has fixed value. DC also known as unidirectional flow of electric charge. DC supply can store in battery in the form of chemical energy and we can recharge it back. This DC waveform will show like a straight line because there is no frequency and no change in direction. Now we understand what is AC supply. AC stands for alternating current. In AC, electron changes its direction according to time changes. AC tends to start from 0, it increases to maximum and then decreases back to complete one positive cycle. Now it increase in opposite direction and then decrease and go back to 0 to complete negative cycle when one positive half cycle and one negative half cycle considered as a one cycle. In many countries 50 Hz frequency is coming as a AC supply. In some countries there is 60 Hz frequency as a AC supply. The frequency means that number of cycles completed in 1 second. This 50 Hz means that 50 cycles completed in 1 second and 100 times changes its direction. In 60 Hz, 60 cycle completed in 1 second and 120 times it changes its direction. In AC, the voltage varies according to time. It does not provide a constant voltage. Now we understand the working of MOSFET. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. It has three terminals. First is gate, second is drain, third is source. It is voltage control device and have high efficiency for switching and amplification. MOSFET also called IGFET. IGFET stands for Insulated Gate Field Effect Transistor. Now we discuss about working principle of MOSFET. When voltage is applied to gate terminal, an electric field is generated that changes the width of channel region. Wider the channel region, the better the conductivity between drain and source terminal. As we increase the voltage of gate terminal, the drain current also increases, and when we decreases the gate voltage, the drain current will decreases and conductivity between source and gate will decreases. MOSFET has two types. First is Enhancement Mode MOSFET and second is Depletion Mode MOSFET. First we discuss about Enhancement Mode MOSFET. In this, positive voltage on gate increases, the conductivity between drain and source increases. For constant voltage VDS, VDS stands for voltage across drain and source. The current flowing from drain to source increases as the gate voltage increased. Thus, the drain current is enhanced by positive gate voltage or potential. As such, this device is termed as enhancement mode. Later we discuss about enhancement mode with the circuit diagram. This is the symbol of enhancement mode MOSFET. This is N channel enhancement MOSFET and this is P channel. Second is depletion mode MOSFET. It is a MOSFET when there is no voltage across gate terminal. The channel show maximum conductance which increases the conductivity between drain and source. When you apply either positive or negative, then channel width is decreases and conductivity decreases between drain and source terminal. This is the symbol of depletion mode MOSFET, N channel and P channel. Now we discuss practically how MOSFET works. This is the circuit diagram. In this we see how MOSFET works when we increase or decrease the gate voltage. I connected source terminal of MOSFET to the negative terminal of battery and I connected negative terminal of LED to the drain terminal of MOSFET. I connected a resistor with the positive terminal of LED to the negative terminal of battery. I connected 5 kilo ohm potentiometer to the gate terminal. I connected variable terminal of potentiometer to the gate and I connected first terminal of potentiometer to the negative terminal of battery and I connected second terminal of potentiometer to the positive terminal of battery. When I increase the potentiometer value, the gate current increases and LED will glow more. If I decreases the drain current, LED will go dim and then off. Now I show you practically. Now I have built the circuit on breadboard. Now I am increasing the voltage of gate terminal. You can see that drain current increases when I am increase the gate voltage. When I decrease the gate voltage, the drain current decreases. In this video, we learn what is AC and DC supply and how MOSFET works. In next video or in next part of this video, we learn how oscillator circuit works and how it modified DC to AC waveform. Thanks for watching.